All right, so we are now going to go ahead and move on to the third unit of the year, or the second chapter in our book. And the first section that we're going to do is this. We're going to review our expansion laws. So everything we're doing in this section, you have learned already, but we're just going to go ahead and review it. So hopefully we can get through this video kind of quickly. But this unit is going to be broken up into two different sections. One where it's going to be expanding or multiplying, and then the other one is going to be where we're undoing the multiplication, which is called factorization, or when we factor. All right, so this unit is going to be broken up into two sections. And remember, in each of these sections and throughout this entire unit, we want to be thinking about our essential questions. And the first one I'm going to introduce in this video is how can writing an expression in two different ways help us understand it better? All right, so it's something that throughout the unit, throughout the chapter, and throughout the whole year is something we constantly should be thinking about. All right, so the first question we're going to do is this a regular distributive law? So anytime that we have a number or a variable that's written next to parentheses like this is telling us that we need to multiply. So one of the first ways that you can do this multiplication is you can just draw your arrow, and that's telling you that you need to multiply, and that's showing your work. So we would do A and then times B plus C. So the first one we can do is A times B, and that gives me A times B. And then the second one, it's A times C. So then A times C will give me A times C. So this is just saying we're distributing the A into the B plus C, and it's giving us A times B plus A times C. So when we have this question down here, to show our work, we can just go ahead and we can draw our arrows saying that that's how we're distributing it. So we're doing 2 times X, so that gives me 2X. And then it's 2 times 3, so that gives me plus 6. And then we need to distribute the 5 into this parentheses because that's how it's written. So it's saying 5 times X minus 4. So 5 times X is plus 5X. And then 5 times negative 4 will give me minus 20. And then after you go ahead and distribute it, you always have to simplify if you can. So here we have 2X and 5X, so they are like terms. And then the next two we have is 6 and negative 20, and they are like terms. So we need to make sure that we're adding our like terms together. So 2X plus 5X is 7X, and 6 plus negative 20 is minus 14. All right, so this 2 times X plus 3 plus 5 times X minus 4 is equivalent to 7X minus 14. All right, so this is one way that you can go ahead and do your multiplication is just by drawing your arrows. I'm going to show you a couple other ways throughout this video as well, and you use whichever one you find best or easiest. All right, so the next set of problems that we're going to do is when we have two binomials that are being multiplied to each other. And a binomial is something that has two terms. So see how we have this A plus B? Well, this is a term and this is a term, so we have two terms. And C plus D, this is a term and this is a term, so we have two terms. All right, so one of the things I want to go through as well is anytime that you have multiple, when you're multiplying or distributing or anything like this, you can always identify if you at least multiplied every number based on how many terms we have. So if we have two terms and we're multiplying by another parentheses that has two terms, that means before we simplify anything, we will have 4 terms. All right, so this is a way that you can identify how many terms you'll have before you simplify. It's a way that we can use to check our work, so that way we know that we have every single term that we should have multiplied, that we didn't miss anything, or that we didn't multiply something twice. All right, and the same thing, one of the ways you can do this is just like we did in the other, is you can draw the arrow, so A times C, so that will give us A times C. Then you can draw your next arrow going to the next number, A times D. Then you can draw from, because now we multiplied A into both of them, we can then draw the arrow from B, so that gives me B times C. And then we can draw our arrow to D, and that gives us B times D. All right, so you can do that if you want, but the way I'm going to show you here is going to be our FOIL method. All right, and these letters, FOIL, stand for words. So this F stands for first, and what that means is we're multiplying the first of each of our binomials. So we will get X times X, or X squared. All right, then O stands for outer, and that means that we are multiplying the outside numbers of each of our, so if we look at our binomials together, it's the two outside numbers, and that will then be a positive X times negative 3, or minus 3X. The I stands for the inside numbers, or the inner, so when we look at these as one whole set of numbers across, it's then going to be multiplying our two inside numbers, so it will be multiplying the 4 times the X, so that gives us plus 4X. And then the L stands for the last. So it means the last two numbers in each of our binomials. So now we're looking at these as two separate binomials again. So it's the last of our first binomial times the last of our second. And that would then be a positive 4 times a negative 3, which is minus 12. All right, so you can use the FOIL, or if you want, like we did up here, you can go ahead and draw the arrow. So X times X, x times negative 3, 4 times x, and 4 times negative 3. Either way, it's perfectly fine. So another thing, remember, we had 2 terms and 2 terms, so we should have 4 total terms before we simplify, and we do 1, 2, 3, 4. Now we'll go ahead and simplify, so we look for our like terms. Well, the only like terms we have are the negative 3x and the positive 4x. So we combine our like terms, so we have x squared plus x minus 12. All right, that would be our final answer for that one. This next one over here, I'm going to use something a little bit different. All right, and I'm going to go ahead and use a table. So we will create a table like we did here. All right, this corner up here never gets filled in, so you can color it in, and the amount of rows and columns you have needs to match the amount of terms that we have that we're multiplying. So here we have 2 terms, so we have 1, 2. Here we have 2 terms, so we have 1, 2. Right, so you can use this table for any size that you're multiplying in the parentheses, but just make sure you have enough spaces for them. So I'm going to fill in this first one here, 2x minus 5. So you fill in the 2x and then minus 5. So the sign stays with our numbers. Here it's negative x and then plus 3. All right, so this here, it's just like a Punnett table that you might have done for science. If you ever did figuring out the odds that genetics, where you'll have blue eyes or brown hair or whatever, big B, little b, you would have used a Punnett square for this, and it's the same thing. So the way that we generate this space is by multiplying the 2 numbers that create it, and that's this 2x and this negative x. So 2x times negative x is negative 2x squared. So that's how we generate this space. Then we generate this one by doing the 2x times the number that's creating it, so 3, so that will then give us 6x. This one is minus 5 times minus x, so then it's plus 5x. And this last one is created by the negative 5 and a positive 3, so that's minus 15. All right, so the good way about this one is that you know that you can never mistakenly multiply 2 of the same things twice. Or you know that you can never mistakenly miss anything, because then you'll have an open space. So this one's very useful when you have maybe 3 terms times 4 terms, or where you have bigger expressions that are being multiplied to each other. As opposed to just a binomial times a binomial, it might not necessarily be the best way, because you can kind of do this one a little bit quicker with FOIL or drawing your arrows. But it's very useful if you have, say, 3 terms times 4 terms. Right? And the other thing that's very useful about this is when most of the time, not all the time, but most of the time, the numbers that you're going to combine will end up being diagonal to each other. So if you see this 5x and this 6x, they ended up being diagonal to each other. And that's how it's going to happen most of the time. Not all the time, but most. So there's nothing that's similar to this negative 2x squared, so it's minus 2x squared. Here we have 5x plus 6x, so that gives me plus 11x. And then here we have just minus 15. All right, and that will be our final answer for that one. All right, so now we're going to expand and simplify again. So here we have 2 terms, here we have 2 terms. So we know before we even get started that we should have 4 terms before we simplify. And I'm going to go ahead and do this one just a little bit quickly, because I'm going to show you 2 ways of doing this. So we can just draw our arrows. So we would have 3x times 3x, which would then give me 9x squared. We would then have 3x times the other number 2, so that will then give me plus 6x. And we have minus 2 times 3, so it's minus 6x. And minus 2 times 2, so it's minus 4. We have our 4 terms that we said that we would. Here we have our like terms. Well, positive 6x minus 6x, they cancel out, so it's 0. So it's just 9x squared minus 4. Right, so this one here that we just did, I'm going to show you another way of multiplying this. Right, so if you noticed, we had 3x and then minus 2, and then 3x and a positive 2. So we had the exact same numbers, just one of them was different signs. So if that's the case, and that's something that's called difference of 2 squares, that's a name that we will use more frequently when we're doing the factorization. But we have the difference of 2 squares here, because that's what it's saying. The difference means subtraction and 2 squares. But from here, if we had the same numbers but different signs, we can just follow this. Meaning the first number is considered a, so we have 3x minus 2, and then we have 3x plus 2. So the very first number that we have in each of our, as long as they're the same, they're considered a. So this 3x is a. And then this minus 2, the one that changes its sign, is considered our b. So what they're saying here is when we have the same numbers with different signs, it becomes a squared minus b squared. Well, we already established that our a is 3x, so we can just say it's 3x squared. And then since this 2 is the one that changes signs, that's the one that is going to be subtracted. And then our b is 2, so it's just 2 squared, right? If the 3x was the one that changed sign, then the 3x would be the one that would be minus behind the negative sign. And then we go ahead and we multiply. So we know that we have to distribute the square into both terms, or into the variable and the coefficient. So 3 squared is 9, x squared is x squared, and then it's minus 4. So you see, no matter which method you use, you get the same answer. This one is just a little bit quicker, and it's going to be extremely important when we go to factor. Right? This is a pattern that you will have to know and have to be able to identify very easily and quickly when we're factoring for sure. Right, the next type of problems that we're going to go through is when we have a binomial squared. So if you notice here, we have 2x plus 1 squared and 3 minus 4y squared. So if we wanted to, we could expand this out. And this is the same as 2x plus 1 times 2x plus 1. And then we could use any of those other methods that we talked about, or we can do 3 minus 4y times 3 minus 4y. And we can use any of those other methods that we did. So if you want to, you can always do this. However, I'm going to show you a formula that we can use that will make this a lot quicker and easier. And this formula is something that we are going to go over in more detail later on, and having this raised to different powers, such as the third, the fourth, and the fifth power. Right, so the formula for this one is if you have a binomial squared, the same thing. The first, we need to denote these as letters A and B. And then so it's A plus B squared is equal to A squared plus 2AB plus B squared. All right, so let's go ahead. So the first thing that we will do for this 2x plus 1 squared is we are going to label the first one as A and the second one as B. And this is then equal to A squared plus 2 times A times B plus B squared. Right, so we just substitute in. So 2x was equal to A, so this is then 2x squared. Plus 2 times A, so 2 times 2x times B, which is 1, so times 1. And then it's plus B, or 1 squared, so we're just substituting. So since we denoted 2x is equal to A and 1 is equal to B, let me highlight those. So 2x was equal to A and 1 was equal to B. We can just go ahead and substitute it into this formula here. So if you want to, you can expand and multiply, or you can use this formula. And then we will just have to distribute. So we know that this means 2 squared, so 4, times an x squared, so 4x squared. 2 times 2x is 4x times 1, so plus 4x, and then plus 1 at the end. All right, so that is our final answer. It's a little bit quicker, a little bit more direct, and being able to use this formula is something that you will have to be able to do later on, because we will be expanding these to the third, fourth, fifth power, and it's something along these lines that you will have to do later on. All right, now this one, both of these numbers were positive, and all these numbers are positive. So you might think, okay, that's there's a different formula for when it's negative. But I'm going to show you what we'll do when it is negative. So let's go ahead and do that problem. I'm going to erase this one, and we'll do that problem. All right. So then the second one we had was 3 minus 4y squared. All right. So the same thing. We need to denote these as our letters. So we know it's equal to a squared plus 2ab plus b squared. So once again, our very first letter or number in our binomial is our A, and our second one is B. So this A is equal to positive 3, and this B is equal to negative 4. So whatever sign is there stays with that B. So the very first thing is we'll substitute it in, so it becomes A squared, but we know A is 3, so that is 3 squared. Plus 2 times A, and we know A is 3, so 2 times 3. B we know is negative 4y, so it's minus 4y. And then it's plus our b squared, so it's plus, and our b was negative 4y, so it's negative 4y squared. All right, then from here, we will just go ahead and do all the math. So 3 squared is 9, 2 times 3 is 6, 6 times negative 4 is negative 24, so this is then going to be minus 24y. And then we have negative 4 squared, so that's plus 16. And then we have y squared, so plus 16y squared. So the way that you should write this is we want to write it with our highest power first, so it will then be 16y squared minus 24y plus 9. Right? So that will be your final answer for this one. So if you notice, the only difference is when this number is negative, the middle sign will change to negative. The first a squared and b squared will be positive, because no matter what sign it is, if you square the number, it will always be positive. So whenever we have a minus sign, the only thing that changes is that plus 2ab we know is going to end up being a minus sign. All right, so that's it for this video.